Okay, so our new chapter, we're going to talk about confidence intervals. And here's where confidence intervals come from. The big question a lot of times is, what's the population's mean? Like, a lot of times we are not able to take a census, so we don't know every single piece of data. So we can't figure out the population. Well, we don't know what the population mean is. So we have to figure it out. And so let's say, for argument's sake, we take a sample. We take a sample of these 5 different numbers. And we go, okay, we took a sample of these 5 different numbers, and let's add them all up on our calculator. 4 plus 5 plus 12 plus 11 plus 7. I get 39. I'll divide that by 5, and, well, we get the mean for this sample is 7.8. There's a couple things we know. We know that if we took a large enough sample, and we did it enough times, this should be approximately the same as our mean sample. But sometimes we don't have enough data to kind of run through all enough times, and we were not quite sure, and we don't have the resources to get enough, and we still need to make a guess. So that's the idea behind this confidence interval we're going to talk about. So we know that this, if we took the data randomly, and it wasn't 10%, that this should be pretty close to the mean, but we want a range to figure out where that true population mean is. And this comic really does a good way of showing that what a confidence interval is. It says, taking a look at the weather tomorrow, the high temperature will be between 40 below and 200 degrees. This guy's never wrong. So our goal is to give kind of like our estimation or what range it should be in. And a lot of times you want to make sure that it's not so large that they don't have some kind of clue. But if we could narrow it down and say, oh, the temperature, I'm like a certain percent confident that the temperature tomorrow will be between 40 and 20 degrees. Well, that helps narrow it down, and you can start picking out outfits. So this is kind of how we do it. We have an estimate plus and minus our margin of error. So in this last example we got ahead, this is our estimate. That's what we're like, hey, the mean's probably around there. Now we have to do plus or minus a margin of error. Here's how we're going to take that in statistics. So we've said, oh, hey, like X bar, that's our estimate. Here is how you find the margin of error, that arrow right there. It's your critical value times the standard deviation of the statistic. So for most statistics, if you remember before, the standard deviation is calculated like this. And here's what they mean by critical value. We know that if we take enough samples, we get a sampling distribution, and the sampling distribution becomes normal. And we actually know a lot about a normal curve. We know between one standard deviation, that would be 68% of the data. We know between 2 standard deviations, this is 95% of the data, about. And we know that between 3 standard deviations, out here at the very far extremes, we know that's 99.7% of the data. So that's kind of where we get the critical values from. The critical values are going to come from the range between this, like how many standard deviations apart these things are. So we're going to say how many standard deviations apart. So again, standard deviations apart is kind of the idea for the critical value. Okay, and that's going to really tell us a really good kind of estimation of where our confidence is. So let's do a couple of examples. Okay, with confidence intervals, there's a couple key pieces of information you need to know. You need to be able to first have a statistic, or where you think the mean is about. The second thing is you need to have a standard deviation of the sample that you found. The third thing that you need to do is you need to find out how many numbers you took for that set of sample. And the last thing you need to do is you need to say how confident you are. Your confidence really comes from your critical value up here. So let's do an example and see. And what I've kind of done is I want to know, like, as I increase my the number of samples I take, does my confidence interval get bigger or smaller? So that's kind of what we're going to try to figure out right now. And then we're going to do the same thing with confidence. We'll increase our confidence and see if that makes our interval bigger or smaller. So the first thing is we start with our statistic. That's our guess. Plus or minus, well, we have to figure out what 95% confidence means. Well, 95% confidence means that I know that it should fall between that middle portion of two standard deviations. So those are two standard deviations apart is where 95% of the data is. So that's why I'm going to put a 2 right there. And then we need to find its standard deviation, which its standard deviation would be 5 divided by radical 10. And I'm going to need my calculator again for this. So let's just do 5 divided by the square root of 10. So 1.58, and let's just times that by 2. So our window is 3.2 about, so it would be between plus or minus 3.2. So my interval would start at around 46.8 and go to 53.2. So we're 95% confident that the true mean value would fall between 46.8 and 53.2. So we're fairly confident that that's where it's going to fall. Let's try it with a bigger sample size. So now our sample size is 20. We have the same mean. It's going to be 2 again. If you think about what's going to happen to our sample, our standard deviation should get smaller. So this interval should be closer. So the more you can make your sample, you don't actually have to make your confidence intervals wide. That's what we should find, but we'll do 5 divided by the square root of 20. That's 1.1, so that's about 2.2. So now our interval would only be between 47.8 through 52.2. And again, it's a little bit closer together, but because we have a bigger sample size, and so we would be this time 95% confident that the true mean or the population mean is between 47.8 and 52.2. Now we're going to do the last one. And again, we're talking about means this whole time. So everything in this discussion is about means. Again, we want it 2 because we want 95% confidence level. And we're going to say, oh, I want the standard deviation of 5 between 30 and it should even be smaller this time. And we'll just assume that's about 1. So we'll round that up to 1 and say, okay. Oh, I guess that would be, if it was around 1, then we'd have to multiply it by 2. So that's 48 and 52. So again, as you can see, as I increase my number, my interval, or how wide my interval is, gets smaller, and that should make sense. We should be the more samples we should make, the smaller we can make our window with the same amount of confidence. Now let's kind of flip the script and see what happens as we increase our confidence, what happens to our interval. Okay, so now we're going to see what happens to our confidence interval size as we change our confidence levels. So this first one, we're not extremely confident, we're 68% confident. So let's see how big our interval is. So that would be 1 standard deviation times, I know we've done this one before, but we should probably bring this up just because I can't remember what we would get. So 1.58, 1.6. So our interval would be between 47.8 48.4 through 51.6. Now that interval is not very big, but again, we're not very confident because we didn't give ourselves a lot of room for error. It seems to make sense that the more room for error you make, the bigger your window should be. So we'll just keep checking. So this would be 50, I forgot to do 1 times there, plus or minus 2 times, because now we're 2 standard deviations apart, 1.6 because I didn't change that. And as we can see, okay, that would be 40, well, that's 3.2, so this is a like 46.8 and 53.2. So again, we can see that that's bigger. And if we do this one last time, oops, we can see that this will even get bigger. But again, our confidence is even greater, so it should make sense that that should be bigger. So this would be 45.2, and the bigger side would be 54.8. So again, as you can see, the more confidence you have, the bigger your interval generally is. The more samples you take, the smaller your interval is, and that should kind of make sense because we should be more confident if we have more samples, and our confidence, the more confident we should be, the bigger our interval is, because we kind of don't want to miss that data. Let's talk about how we kind of interpret this stuff, though, because it really has like some weird things. So a lot of times what we say between like our intervals is we say, like, calculating intervals, we should capture the true mean in 95% of all samples of this size. So if we do this and we keep doing this, everything with the same sample size, 95% of our confidence intervals should capture the true mean. So that's what we mean by like our confidence there. Along with that, like, really that's what we want to say with the confidence interval. This is the kind of language you want to use when you say those things, like we are 95% confident is a shorthand for saying 95% of all samples of a given size from this population will result in an interval. So as you can see, like over here, if you're 95% confident, like these are our intervals. These are your red dots were your means that you found, and you see that, oh, most of the time we capture them and one of our confidence interval misses. If we were 100% confident, that means every confidence interval of that size that we take will hit the true mean, which means it should be a little bit larger. And if you are given the confidence interval, you would want to say we are blank % confident that the interval from blank to blank captures the actual value, whatever % of the time. So you really want to be like kind of careful with your language. Confidence intervals are really just used to say, hey, we don't know what the population is. We're giving you this interval. We're going to be right whatever % of the time that we say based on our confidence. And we use kind of those normal curves to say like what percentage it should fall in. So try these different examples. If you have questions, please ask.